NASA's Artemis mission intends to put humans to the moon for the first time since the Apollo 17 mission 50 years ago. The Space Launch System, the most powerful rocket ever built, will carry all the spacecraft that makes up the Artemis missions. But what is so different about this Artemis mission? Here's all you need to know about NASA's ambitious plans to return to the moon. SpaceX's Inspiration 4, which somehow launched a person into orbit, and NASA's DART, or Double Asteroid Redirection Test, a model for planetary defense, to mention a few, were just some of the groundbreaking achievements we witnessed in just a year. We got amazing pictures from the Mars rover Perseverance and its friend, the helicopter Ingenuity. We also learned more about exoplanets and faraway stars than we ever thought possible. The year 2022, on the other hand, appears to be a much more promising year. For starters, the space race has returned. A number of international organizations are planning to venture into deep space in order to learn more about the cosmos's most elusive mysteries, including NASA, the European Space Agency, the Korean Aerospace Research Institute, and the Indian Space Research Organization. Specifically, NASA is preparing for its Artemis 1 mission, which will put an unmanned spacecraft into lunar orbit in order to plot a course for future missions that will involve a crew. NASA chose SpaceX to build the first crewed lunar lander for the agency's Artemis program in April 2021, with the goal of putting astronauts on the moon in the mid-2020s and establishing a sustainable human presence all over Earth's nearest neighbor by the end of the decade. Additionally, the Artemis missions will be the first to bring a woman and a person of color to the moon's surface. How the whole Artemis mission will work? Well, let's get into the details. The Rocket Lab Electron spacecraft carrying NASA's Capstone satellite was launched this week, the first stage in NASA's plan to return to the moon in 2022. This coming year, NASA will begin setting up shop in lunar orbit with research and surveillance missions that will build the framework for future lunar trips by humans. The Capstone is the first step, but it's a critical one. These 3 missions are scheduled to take place between this year and early in 2023, including the CubeSat, which was launched this week, and a Lunar Pioneer. Taking a closer look at these 3 missions, it's clear why NASA and its partners prioritize these setup launches. SLS Lunar Autonomous Positioning System Technology Operations and Mapping Experiment is a 6-month-long project. As part of the Artemis program, it's rumored that it will assist in navigation and help sketch out a safe orbit for future spacecraft like the planned Gateway Station. Launched on a Rocket Lab Electron rocket, the 55-pound CubeSat has solar panels, a camera, and several antennae for navigation and communication. Advanced Space developed it for NASA for $13.7 million and is the first commercial firm to operate in a 3-body orbit around the Earth. A leak was discovered in the core stages, bleed-fast disconnect of its SLS rocket during the most recent wet dress rehearsal on June 20th. NASA officials are certain that the SLS is ready to go into orbit and are aiming for an August launch date. SLS was finally able to reach full capacity for the first time despite the leak. NASA plans to repeat the mission to lunar orbit in 2024 on Artemis 2 and then transport humans back to the moon's surface in 2025 on Artemis 3. It's a CubeSat, but the Trailblazer's job is to keep an eye out for the Artemis landers. Spectrometers and thermal mappers are part of its arsenal with the hope of locating where our astronauts should land and setting up future operations on the moon based on the distribution of water ice. Until 2023, the satellite will be ready for launch. Because of NASA's tight timetable, the IMAP flights had to be delayed until 2025 so that the primary equipment could be complete. After all, the IM-2 mission's primary objective will be to transport a second fully automated lander to the moon's south pole, where it will conduct research and dig holes. A SpaceX rocket will carry this out in early 2023. Aware of the need of completing this mission as quickly as possible, NASA has increased the number of launches and overcome obstacles in order to meet the tight deadline set forth by the mission. The static firing of the Raptor 2 engines on Booster 7 will be the next major test. Due to the fact that these engines have never been fired at this size before, it's likely that SpaceX will elect to fire single engines first, then a full ring, and eventually, if all goes well, the entire 33-engine burnout. This information comes from the FAA ruling. There's a lot going on at Starbase right now, including the construction of a crane. At the very least, the Mega Bay's tallest portions have been demolished, indicating that construction on those portions of the facility is nearly complete. In addition, the gigantic Star Factory structure appears to be coming together swiftly, with roof work apparently taking place. It appears that SpaceX's year-long cooperation with the FAA has finally paid off. The true goal is to build on the Artemis Accords, which are headed by the United States in order to achieve peace and, critically, sustainable exploration of outer space. As our orbit becomes increasingly crowded, our Astro Carta would promote peaceful cooperation and high ideals matched with a solid plan for action, ensuring some amount of safety for all parties working in that orbit. Relativity Space has launched its first 3D printed rocket, Terran, from their freshly constructed launch pad at Cape Canaveral Space Station. Terran 1's 9 3D printed aluminum boosters weigh 9.3 tons and are primarily constructed of 3D printed materials. It is the world's largest 3D printed item, made up of 85% 3D printing. Payloads of up to 1.3 tons can be transported in this rocket. They're not the only ones vying for a slot in the small satellite industry. This coincidentally coincides with the launch and certification of 2 more rocket startups. During the summer of 2015, both Firefly Space in California and Able Space in Alaska will be testing identical rockets. Although the Alpha rocket is significantly more expensive than the other 2, it has already successfully static fired its first and second stages, putting it in first place for launch capability, with a scheduled launch sometime in July. Terran 1 and Able's RS-1 are both in the same predicament. RS-1, on the other hand, uses more traditional welding methods and had a big setback during their initial effort to qualify for the higher stage of the competition. SpaceX hopes that its Terran 1 will be the first step for 3D printing rockets on Mars and beyond, while all 3 businesses are looking for fast launch cadences on a budget. It's likely that both the Able RS-1 and the Terran 1 will be ready for launch in August, pending the results of booster qualification tests. It was on June 23rd that the UK announced a range of measures, including legislative and financial activities, to deal with the rising debris problem in low Earth orbit. A global commercial framework for insurability is the ambition of the Minister of Science, Research and Innovation, George Freeman. It is our goal to lower the cost of commercial satellites for those who adhere to the most stringent sustainability standards. He's right that we need to incorporate sustainability into our business practices. There are commercial solutions being tested by companies like NanoRacks and Astroscale to this challenge. Who knows what creative new solutions they could come up with if they could get some support. This means that the UK strategy is fourfold. The first step is to establish a regulatory framework for all space activity. A plan is essential to solving an issue, so getting one started there is a no-brainer. We seek industry and government. Britain hopes to engage with the US and G7 nations to promote the sustainability framework and create simple metrics for analyzing the long-term viability of future space missions. Regulations are useless if a company's compliance with new standards can't be measured, or if the procedures to measure compliance are too difficult. Freeman says companies who follow the new rules will enjoy lower orbital licensing insurance expenses. A debris cleanup effort will be funded with $6.1 million. In the second half of summer, 2 firms will be chosen. Remember that contracts awarded last year to a group led by Astroscale, who recently tested the viability of cleanup operations with their LCD satellite, are the next stage in a program-wide strategy. And that brings us to the end of the video. Feel free to let us know what you think about the video. And if you liked it, please leave a like and subscribe to our channel for more things. And thanks for watching. We'll see you in the next one. See you.